In this nugget, we will cover the third default network in Docker, which is the none network. If we want to completely disable the networking stack on a container, we need to use the none network for the container. In this case, within the container, only the loopback device is created. On the Docker host, let's run the inspect for none. So Docker network inspect and none. There are no containers using this network. Okay, so we will now run a Tomcat container using the none network. So Docker run itd rm -- network, and it is none. Let's give this a name, that is Tomcat1, using the latest image of Tomcat. Okay, so now run docker ps to check its status, which is running. We will now do an exec to this container. So let's go ahead and docker exec it tomcat1 bash. So we are inside the container now. Okay, now let's run ip add show inside this. Okay, and what do we see? There is just the loopback interface, which is expected. Okay, so with none network here, none network type, there is no network type available to the container at all. That's what we have learned in this particular section. There are three default networks created on a single host upon the Docker installation. These are bridge, host, and none. We can run the command docker network ls on the Docker host to see that. So let's get back to here. Observe that there is a network ID associated with each network. Also, there is a driver and scope. Driver for bridge is bridge only. Driver for host is host, and the driver for none is null. As you can see, the scope for all of these is local to the Docker host. Let's check on the network drivers on the Docker host in this state, that is post Docker installation. Let's run the command ifconfig. Okay, now if you see the Docker 0 network interface, which is listed along with the eth0 and loopback interfaces, instead of ifconfig, we can also run ip add show, as ifconfig has been deprecated on few operating systems. So that command also can be run. Okay, if while running a container we don't specify anything about the network to be used, then each container connects to Docker 0 network interface of the host. Also, a point to understand here is that the default Docker network that is used by the containers is the bridge network. Hence, which is obvious as well, that the bridge network represents the Docker 0 network on the host. Hello everyone. In this nugget, we will understand the bridge network type and put it into implementation on our test deployment. As we learned in the last slide, default network type for all containers is bridge network. Containers are run on a separate network stack on a completely separate network namespace, which is internal to the Docker host. It is basically a network address translation which is configured within the host itself. Multiple containers running on the host have an internal IP address each, which is then translated by the bridge network definition. As soon as a new container is spun, Docker automatically creates a masquerade rule that lets the container connect to the external network. We can run the command docker network inspect bridge to get information about this network. So let's get back to the host. Docker network inspect bridge. Right now, there are no containers running on the host which are using this network. Here you can see the subnet range configured for this network and also the IP gateway IP address, which is the Docker 0 IP address. The IP address here is 172.171.0.1. Now let's run the ipconfig to check that. Here you see the IP address is same as we saw earlier. Now let's start two containers on the Docker host. So let's get back to the host and we will type it docker run itd name. The name will be nginx1 and the port that we're going to use is 80. Okay, and the nginx latest image. So once that is done, we will run the other container for the Tomcat. So run itd tomcat1 and the port is 8080 and the latest image of Tomcat, of course. Now run the command again to inspect the bridge network. Let's do that. Docker network inspect bridge. Okay, so now you can see that there are two containers using this network interface. Nginx1 has got the IP address that is your 172.17.0 and 2, and the Tomcat one has got the internal IP address as this is 17.0 and 3. So these are all internal IP addresses. Now let's go to the Docker PS at this point. Inspect the running container for Nginx using docker inspect command. Docker inspect, and then we will give the container ID for the Nginx container. Here also you can see the information about the network used and the IP addresses provided, right? Similarly, yeah, so this is the IP address provided. Similarly, for the Tomcat container, let's inspect the container using the container name. You can use the container name or the container ID, it doesn't really matter. So docker inspect tomcat1. Here also you see the similar results as we saw previously. Okay, so the internal address are assigned automatically through DHCP in the private range. We need to publish the private container port to the host networking namespace in order to enable communication to and from the outside world. In the above example, we published port 80 and 8080 for Nginx and Tomcat respectively. These port numbers were the container port numbers that were to be made open. We did not specify the port number for the host, which will be used for routing the communication. In such cases, Docker assigns a random port number in predefined range. Now let's run the Docker PS again to understand this. The external port numbers are mentioned under the ports with access to all IP addresses. Let's access it from the external network on these ports. Okay, so the IP address for our Docker host is 34.73.210.93. So let's have a look at that now. 34.73.210.93. Okay, we will first try to access it through 32769 for the Tomcat, right? And for the Nginx, we can use the 32768 port number for the Nginx. Okay. Now, instead of leaving the external port numbers to be decided by Docker, we can specify them while running the container itself. Mappings are configured with the flag -p or publish followed by the external port : internal port. Let's run the another Nginx container. So let's go back to the host and say docker run itd rm and the name is nginx2. This time we are using the -p and we are assigning the 32,000 port, external port, and the internal port would be 80, and Nginx using the Nginx image. Here I have used the external port as 32,000 and is mapped to the internal port 80. Similarly, now let's run Tomcat container. with this information. Okay, so let's go ahead and run the docker run itd rm name equals to tomcat2. This time we will use the port number as 33,000 external port number, and we will map it to the internal port 8080 and Tomcat. Here we have used the external port as 33,000, which is mapped to internal port 8080 in this case. We will run the docker ps command now, and as expected, the defined external ports are used. For Tomcat 2, the external port is 33,000. For Nginx, it is 32,000. We can access them from the browser as well. So let's go back here. Okay, so let's try and access it from there. 3, and here we can give 32,000 for the Nginx, and similarly we can give it 33,000 for our Tomcat. Okay, now if we provide an external port which is not free, error should be given. Let's see by running the command, the docker run for the similar port. So let's go back here and let us run the docker run itd name tomcat3. Let's try to run the tomcat3 with the same port. Okay, so there's 33,000:8080 Tomcat. Okay, and let's put enter. As you can see, it errors out. It has some errors saying bind for 0.0.033,000 failed. Port is already allocated. So this way, if we provide an external port which is not free, it is going to be erroring out because it cannot start that particular container at that particular, listening to that particular port.